In modern computing, doing the actual math is, well, it's incredibly cheap. But moving the data to do that math, that will absolutely bankrupt you.
Oh, totally. I mean, from an energy standpoint, moving just a single piece of data across a server board can cost like hundreds of times more power than the actual calculation you perform once it finally gets there.
Right. And when you are running artificial intelligence models with hundreds of billions of parameters, that data movement isn't just some, minor inefficiency anymore. It is a physical wall.
A massive wall, and we are literally watching the entire tech industry slam into it at top speed.
Which brings us to the deep dive today. Welcome, everyone. We have a remarkably concise but highly impactful stack of sources to go through with you.
Yeah, it's a brief snapshot, but it is heavily loaded.
Exactly. We're looking at an April 19th Reuters report, which is actually citing an earlier weekend report from the tech publication The Information.
Right, the Sunday leak.
Right. And the entire leak hinges on one core fact. Alphabet's Google stock ticker, GOOGL, is reportedly in deep talks with Marvell Technology, ticker MRVL.
And their stated goal, according to the report, is to develop 2 new chips aimed at running AI models more efficiently.
Which sounds simple, but our mission today isn't just to report that rumor to you. It is to read between the lines of this brief financial reporting to understand exactly what they're building.
Because the physical architecture of AI hardware is fundamentally fracturing just to survive.
Yeah, and to understand where AI is going, you have to understand the metal it actually runs on.
And that requires, reading really closely into what isn't being explicitly stated. When massive players like Google and Marvell leak talks about custom silicon, the specific phrasing they use acts as a blueprint.
Like a blueprint for their whole capital expenditure strategy.
Exactly. It tells you where all the money is flowing.
Okay, let's unpack this. Yeah. Because the exact phrasing Reuters uses is that these two companies want to develop 2 new chips aimed at running AI models more efficiently.
Right. Running them.
Yeah. The focus is entirely on running the models, which in the industry we call inference, and doing it efficiently. My question is, why is that the headline?
What do you mean?
Well, the public narrative is always about making AI smarter, right?
Yeah.
More capable of reasoning, generating video. It's like we built these massive gas-guzzling supercars, but the back-channel hardware narrative here is suddenly obsessed with fuel economy. Why efficiency?
Well, because brute force scaling has just reached its terminal velocity. For the past few years, the race really has been all about training.
Right, feeding massive clusters of GPUs the entire internet just to build the models.
Exactly. But training is a one-time massive energy expenditure. What this report highlights is the pivot to inference, running the models.
So the day-to-day usage.
Yes. Think about it. If you have an AI model integrated into every search query, every map route, every single email drafted by billions of users every single day, you are no longer doing a one-time calculation.
You're doing continuous infinite processing.
Exactly. And the current hardware architecture simply melts under that kind of continuous load.
I mean, we are literally talking about data centers that require dedicated nuclear power plants just to keep the lights on, right?
Yeah, and the cooling system's running. You just can't scale a product to the entire planet if every single prompt dims the local power grid.
Right. So when the source text emphasizes running models more efficiently, it's really a coded admission.
Very much so. It's an admission that current general-purpose AI hardware just draws too much power, generates way too much heat, and costs way too much to operate at a global scale.
So we've hit a thermal and economic ceiling.
Precisely. And the only way to break through that ceiling isn't to just build a bigger chip. It's to fundamentally change the geometry of how a chip operates.
Which leads directly into the actual hardware mentioned in the leak. Because the Reuters report explicitly states they are discussing not one overarching processor, but 2 distinct chips.
Right, they are splitting it up.
Yeah. The first one is described as a memory processing unit designed to work with Google's tensor processing unit, or TPU.
The master chef and the sous chef.
Right, it's like a master chef in a busy kitchen. If the TPU is the master chef doing the heavy lifting of cooking, the new memory processing unit is a dedicated sous chef hired specifically just to fetch and prep ingredients.
But his chef never has to stop working.
Exactly.
Yeah.
But I want to push back on this architecture a bit. Because we just established that moving data is the most expensive part of the process. Standard architecture physically integrates memory controllers and processing cores as closely as possible, right?
Yeah, to minimize that distance.
So why on earth would Google and Marvell reportedly design a totally separate unit just for memory?
Yeah.
Doesn't decoupling them physically increase the distance the data has to travel? Doesn't that defeat the whole purpose of efficiency?
What's fascinating here is that your pushback hits on the exact paradox of modern AI architecture. You're absolutely right that you want memory and compute physically
Yeah.
close.
So why separate them?
Because we have run headfirst into what computer scientists call the von Neumann bottleneck. In traditional architecture, the processor is constantly idling, just waiting for data to be fetched from memory.
Oh, because the compute speeds have scaled exponentially faster than the memory bandwidth speeds.
Precisely. The processor is essentially starved of data most of the time. And in a massive language model, the processor needs to access billions of different weights and parameters for every single token it generates.
That sounds like a logistical nightmare.
It is. The routing logic required to fetch, organize, and then feed that staggering volume of data to the compute cores has become incredibly complex.
So if you force the main TPU to handle all that traffic direction,
You are using precious, power-hungry compute transistors to do basic logistics.
I see. So by building a separate, dedicated memory processing unit,
Which is exactly what Marvell is specifically known for, by the
Yeah.
way. Specialized networking and interconnect silicon.
right, so you are offloading the logistics. The physical separation isn't about moving the memory further away. It's about pulling the traffic controller off the main processing die.
Yes. To free up that critical silicon real estate, you build a custom piece of silicon whose entire physical architecture, like every logic gate, every transistor, is optimized for one single thing: high bandwidth data routing.
So it doesn't even do math.
No math. It just flawlessly orchestrates the movement of terabytes of data from the memory modules into the TPU exactly when the TPU needs it.
And this separation of duties drops the energy footprint.
Massively. Because each chip is only drawing power for the exact task its physical structure was optimized to perform.
That makes the inclusion of Marvell in this league make perfect sense then. Because Google has been designing its own TPUs for over a decade. They know how to do the math.
Oh, absolutely. They don't need help with the math.
Right, but Marvell specializes in data infrastructure, custom interconnects, moving massive amounts of information seamlessly. If Google is hitting a wall with memory bandwidth logistics, Marvell is exactly who they would call to build the custom switch.
It's basically an acknowledgement that the bottleneck isn't the AI algorithms anymore. It's the networking inside the hardware itself.
But the leak doesn't stop at the memory unit. The sources indicate a complete overhaul of the processing side as well.
Right, the new TPU.
Yeah, the excerpt notes they're also discussing a new TPU built specifically for running AI models. And here's where it gets really interesting for me.
How so?
Well, the phrase built specifically for running AI models feels, I don't know, almost redundant at first glance. Google's entire TPU line, the tensor processing unit, was theoretically built for AI.
Yeah, that is literally what the T stands for.
Exactly. So what does the phrasing built specifically actually imply here? Weren't previous chips already running AI? To me, it suggests that their current or legacy TPUs are somehow no longer specific enough for where the models are going.
This raises an important question about the life cycle of custom silicon. You have to remember that hardware development cycles take years.
Right. It takes forever to design and fabricate a chip.
But software development in AI is currently iterating every few months. So the architecture of a TPU designed, say, 3 or 4 years ago was optimized for the AI models of that specific era.
You mean things like convolutional neural networks for image recognition?
Exactly, or deep learning recommendation models.
Models that have vastly different mathematical structures than the massive trillion-parameter large language models we're seeing right now.
Precisely. A legacy TPU, even if it's designed for AI, still carries all this architectural baggage. It has instruction sets and physical pathways designed to accommodate a much wider variety of mathematical operations.
So it's doing things it doesn't need to do anymore.
Yeah. It might have silicon dedicated to high-precision floating point math, which was totally necessary a few years ago, but modern LLMs rely heavily on low-precision math.
Right. They don't need 12 decimal points of accuracy. They just need speed and volume.
Exactly.
So the legacy chip literally has entire blocks of silicon just sitting dark, drawing idle power, because the new software simply doesn't use those specific mathematical pathways anymore.
And in the pursuit of absolute efficiency, dark silicon is a massive liability. So when the report says built specifically for running AI models, they are talking about stripping the die down to the studs.
Removing anything that isn't essential.
Yes. removing any instruction set architecture that isn't actively used by a modern transformer model or whatever next-generation sparse architecture they are deploying. They are carving the hardware into the exact physical shape of the software algorithm.
Wow, so it is hardware-software co-design taken to its absolute unforgiving extreme.
Totally.
You take the memory routing logic and physically excise it onto its own Marvell-designed chip. Then you take a compute die, strip out all the legacy AI math, and leave nothing but the hyper-specific pathways needed for modern inference.
And you end up with a highly fragmented, violently specialized hardware stack.
But I want to pivot here because the architecture is really only half the story.
Yeah.
The way this information actually reached the public is just as vital to understand. Let's look at the anatomy of this tech leak, because the paper trail provided in the source text is very explicit.
Yeah, the lineage of the information tells its own story.
It really does. Look at the sequence here. The primary text we have is an April 19th Reuters report, which was Wednesday.
Yeah.
But Reuters is carefully citing a report from the previous Sunday, published by the information.
Right.
And the information is citing two people with knowledge of the discussions. So what does this all mean? For you, the listener, who is just trying to stay well-informed, how should you process this?
It's a great question.
I mean, I push back on the certainty of this news. Given that this is based on unnamed sources in talks, I look at a Sunday leak to a specialized Silicon Valley publication, and I immediately question the reality of the hardware. Is this an actual finalized chip architecture currently sitting in a fab being printed, or is this just a glimpse into corporate strategy, a trial balloon?
Well, if we connect this to the bigger picture, the distinction between finalized silicon and strategic trial balloon almost doesn't matter.
Really? Why not?
Because the financial impact is identical either way. You have to look at how capital flows in the AI space. Currently, the narrative is entirely dominated by the massive margins and market share of the primary GPU manufacturers.
Right.
And the companies actually buying those GPUs, like Google, are spending tens of billions of dollars on capital expenditures, which terrifies Wall Street because it crushes their profit margins.
Right. Investors are looking at Google's balance sheet and asking, how long can you afford to buy these massively expensive, power-hungry general GPUs just to run your search engine?
Exactly. So how do you calm the market? You orchestrate, or at least permit, a leak.
Ah.
Releasing this to the information on a Sunday is a classic playbook maneuver. It gives the venture capitalists, the institutional investors, and the tech analysts 24 hours to digest the narrative before the markets even open on Monday.
And then by the time a global financial wire like Reuters picks it up on Wednesday, the narrative has completely crystallized.
Yes. The story becomes Google has a proprietary, hyper-efficient hardware strategy in the pipeline.
It's a signal to Wall Street that says, hey, we aren't going to be hostage to third-party hardware margins forever. We are building the escape pod.
Exactly.
And notice that the source text explicitly includes the stock tickers GOGL and MRVL right up front. This isn't just engineering news. It is a financial directive. Whispers of efficiency move markets, regardless of whether the chips are finished.
And it serves Marvell equally well. I mean, Marvell needs to signal to the market that their custom silicon and interconnect IP is viable at the absolute highest levels of AI infrastructure.
And a leaked discussion with Google instantly validates their technology stack.
Totally. It doesn't matter if the chip takes 3 years to tape out or if the design pivots wildly between now and production. The market valuation reacts to the intent of efficiency.
It also acts as a massive recruiting beacon, doesn't it?
Oh, absolutely.
If you are a top-tier silicon engineer specializing in memory bandwidth logistics, and you read this Reuters report, you suddenly know exactly where the most heavily funded cutting-edge project in the world is happening. You don't leak unfinalized architectural talks unless you want the ecosystem to react to them.
Right. It is corporate strategy executed through the press, leveraging the word efficiency as the ultimate market catalyst.
It is brilliant, and honestly, it is ruthless. We've traced this from the literal physical distance data has to travel on a motherboard all the way up to the macroeconomic game theory of Sunday tech leaks. But let's bring this all back down to you, the listener.
Yeah, why does this actually matter to people outside of Silicon Valley?
Exactly. Why should you care about a rumor regarding a fragmented TPU and a custom memory switch? Because these components are the invisible infrastructure of the future. The physical limits we just discussed are going to dictate the speed and capability of every AI tool you use.
That's a really good point.
We are currently in an era where AI seems boundless. Like we can just ask software to do anything and it will eventually figure it out. but software is ultimately anchored by metal.
It has to run on something physical.
Right. If companies like Google and Marvell cannot fundamentally redesign silicon to solve the latency and thermal walls of data transfer, the exponential growth of AI capabilities will violently stall. The cost of running these tools will remain astronomical, limiting who actually gets access to them.
Yeah.
The hardware efficiency they're reportedly trying to achieve right now is the invisible infrastructure that will determine if AI becomes a ubiquitous, invisible utility or remains an expensive, gated luxury.
It really is the physical foundation that the entire digital future is waiting on. And, stepping back to look at this whole dynamic leaves me with one final kind of provocative thought for everyone to mull over.
Let's hear it.
We just spent this time dissecting a leak that points to the extreme fragmentation of computing hardware. We are breaking the ship apart, isolating the memory logistics onto one custom piece of silicon and carving away legacy architecture to leave a hyper-specific single-purpose AI compute engine on another.
Unprecedented hardware specialization.
Right. Yet the actual AI models we are running on this hardware are doing the exact opposite. The software is becoming incredibly generalized.
Oh, wow. Yeah.
We're moving away from specific AI models for image generation, separate models for text, separate models for code, and we're moving toward unified multimodal models capable of reasoning across all domains simultaneously. The software is becoming a master of all trades, striving for generalized intelligence.
That is fascinating.
Isn't it profoundly ironic that to support an increasingly unified and boundless digital mind, the physical metallic brain required to run it is being forced to become more fractured, rigid, and intensely specialized than ever before?
That is a staggering contradiction to leave on. The software trends toward infinity, while the hardware is brutally constrained by the physics of reality. It's an incredible tension to watch play out. Thanks for joining us on this deep dive. We'll catch you on the next one.